We'll proceed in pseudo algebraic, pseudo calculus problems. Okay, pseudo calculus problem where it will take us to a statistics. So that's why we are giving this much emphasis. This will take us to statistics. And if it takes us to statistics, that's why we are giving this much emphasis upon the pseudo calculus problem, upon the repeated summation. The repeated summation is a concept that works very well in probability. Generally, what is probability? What is statistics? Probability is nothing but either it is summation or it is multiplication. Okay, whatever the outcome we are getting, whatever outcome we are getting, or what is the event we are having, the probability of the event, whatever. If I have so many probabilities, either we sum it if it is mutually exclusive, or we multiply it if it is mutually independent. Mutually exclusive, we multiply each item. If we have the probability, we add it. Of it is mutually independent, then we multiply. That's it. Whatever it is, we do repeated summation and we do repeated multiplication. Repeated summation, repeated multiplication. Repeated summation can be resolved into integral calculus. This is what we are seeing now. Repeated summation into integral calculus. This transformation, if someone understand very well, then world is in a way that I won't say that he will be master in artificial intelligence or whatever, but certainly he will be master in solving the probability problem. If any problem is in a probability and he is able to find solution in repeated summation, then one time will come where he will not find the exact solution through the repeated summation. He has to think about integration. When, how, that slowly we will see. Anyway, we are in phase of we calculated the circumference of a circle through repeated addition. Circumference of a circle through repeated addition. How we calculated? We divided our circle into n part. Okay, and then each part I calculated the arc length and then I summed it. Okay, then I came to know that the one part, okay, one part, if I take for the repeated summation, okay, if I take one part in the repeated summation, then the curve length in one part. If I take repeated summation, the curve length in one part is delta x whole square plus delta y whole square root. Okay, this is what we have seen. What is the concept we are bringing here is, okay, the concept what we are bringing here is that repeated summation should be transformed into integration, and we have seen very well. Repeated summation, if I want to transform into integration, and we are calculating repeated summation of a, we are trying to calculate circumference of a circle. Okay, this is very important. I am trying to calculate circumference of a circle. How I calculate? This is x-axis, this is y-axis. Okay, we are trying to calculate through repeated addition. Now, how we calculate it? Consider this is x-axis and this is y-axis. In that fashion, the center of this circle, it coincides with the origin. Okay, in that fashion now we can say this is this is x-axis, this is y-axis. Hope it is not possible. How I can draw circle center at here? Where is your radius? Radius starts from here only. This is the radius. And radius is shrinking if I am moving the angle, and radius becomes 0 when angle is 90 degree, and when radius proceeds, radius is negative. This side radius is positive, and it proceeds, and it complete only 180 degree. It makes a circle r equal to cos theta. If r equal to cos theta, radius can be function of theta, y can be function over x, x can be function over y, theta can be function over r. r theta is a separate coordinate system, that is called polar coordinate system. X and y is separate coordinate system, and it is called Cartesian coordinate system. In that sense, y can be dependent upon x. If that is the case, if y is not dependent upon x, then typically it forms a rectangle. If y is dependent upon x, then where x and y are orthogonal to each other, but if I draw a line on xy plane and y is dependent upon x, y is fx, then it can make any line that is not a rectangle. It can make a circle, it can make ellipse, it can make a parabola, whatever it is. Similarly, I have r theta plane. If r is constant, not dependent upon theta, there also it will make a rectangle. Otherwise, it will make any shape. R equal to cos theta. In r theta plane, it will make a cos sign, cos wave. It will make a cos wave. If this is theta and this is r in theta r plane, if I say r equal to cos theta, then it will be at theta equal to 0, r will be 1, and then it will make a cos sign, cos wave. Here in xy plane, if this is x-axis and this is y-axis, and y, that is the height, is function over x, y equal to a square root of a square minus x square. In that fashion, it will make a circle. Okay, y equal to x square. In that fashion, it will make a parabola which will have dip minimum point at origin, and it will go like this. Make sense? Depends upon what is the relationship between x and y. There is a third thing that is called intercoordinate system. This is xy coordinate system and this is r theta coordinate system. Intercoordinate system relationship. If x equal to r cos theta, y equal to r sin theta, if that is the case, then if I have a rectangle in theta r plane, that rectangle will be mapped here as a circle. Okay, one thing. Second thing, in theta r plane, if it is rectangle, means r is not dependent upon theta. If r is dependent upon theta, r equal to cos theta. In that fashion, if I map it here, it will again be a circle. This is what I am trying to say. How that circle will look? If r and theta are not dependent upon each other in theta r plane, then it forms a rectangle. Any plane, if two orthogonal sides are not dependent upon each other, it will make a rectangle. Here also it will make a rectangle in r theta plane. That rectangle, if mapped into xy plane with the relationship x equal to r cos theta and y equal to r sin theta, it will form a circle which will be centered at the origin. It will form a circle which will be centered at the origin. Okay, but if I make r dependent upon theta, r equal to cos theta, if I do like that, then there it will be cosine wave in r theta plane. That will be mapped here again as a circle. But circle will be like this, where circle is not centered at the origin. This is the origin and circle is not centered at the origin. Circle is little bit away. Left side of the circle is passing through the origin. So that is the mapping of r cos theta into xy plane. If r and theta are independent, then mapping will be a circle that will be centered at the origin. I believe it is all right. It is like that. Okay, so that is the idea. Now we are trying to calculate the circumference of a circle through repeated addition. Means if this consider this is centered at the origin, then this is the origin. This is the origin. Now radius start moving like this. It is at x. This is x axis. This is y axis. Radius is at x axis. Radius starts moving like this, and it forms many sections. One section, second section, third section, fourth section, fifth section. Like that, I divide the circumference into n sections. If I try to calculate the one section length, then another section length, if I know all the section length and add it, it will give the circumference of the circle. I believe it is all right. Obvious, right? Okay, how to find it? Then consider that this is the first section. This is the first section of the circumference. This is the second section. This is the third section of the circumference. This is the ith section of the circumference. This is the ith section of the circumference. In that way, this is the arc of the ith section. What is the length of this arc? Length of this arc is P, capital P, bottom right small I, ith section perimeter. Capital P, bottom right I. Now if I add all the I get the full perimeter. Summation of I equal to 1 to n. I have divided into n part. Summation I equal to 1 to n, and then p parameter of the ith section. If I add, I get the parameter. What is the parameter of ith section? Someone would jump quickly that I know, this is radius, then this arc will be radius into this angle. Consider that from x-axis this angle is theta, and then this radius is moving, making the ith section, this angle is delta theta I. Delta theta signifies a period, one gap. Delta theta ith section, this is the angle. Delta theta I into r is this arc, but not necessarily that radius is constant. I can take the circle, I can take a circle not centered at the origin. I can take origin here also. I can take origin here also. Then it will not be a polar coordinate, it will be a polar coordinate. Anyone would say if take origin here, then you can identify the circle in x and y, shifted circle. All right. But it cannot be in polar coordinate because polar coordinate need that circle will be at the circle will be centered at the origin and radius will move like this. This is polar coordinate. This is also a polar coordinate where r equal to cos theta. If r equal to cos theta, if I take, then circle will be drawn like this where origin is here and this is the x-axis, this is the y-axis. Where radius will start at the angle 0. Where radius will start at angle 0, true, but as angle is growing, radius will start shrinking. And when angle is 90 degree, this radius completely shrink to 0. When angle is growing beyond the 90 degree, radius will be negative, r equal to cos theta. Negative. When angle is 180 degree, then it will move like this and then it will move like this. But radius is negative. If radius is negative, to get it positive, I'll change the direction. There is no difference between negative and positive. Negative is reverse of the positive in direction. That's it. So if this is the negative going in this direction, I can just reverse it. This is the positive going in this direction. So radius will start moving like this and it will form a circle r equal to cos theta. In that fashion, for the ith arc, for the ith section arc, I cannot say it is r into delta I because r is function of I, and if r at the beginning is this much, after delta theta I, r can be this much big only. R is decreasing. If I say r into delta theta I, it will be give arc in this fashion. But we want arc in this fashion. In that way, we went to get help from the Cartesian coordinate system. If I consider this as point x comma y, and then it moved angle delta theta I, and this point is x2 comma y2. This is x comma y, this is x2 comma y2. In that fashion, there is a change in x, and consider this change in x is delta x, that is x minus x2. There is a change in y, that is y minus y2. Don't think negative and positive, just the change. So if I consider the change in x is delta x, and change in y is delta y, then delta x is x minus x2. Delta y is y minus y2. If I consider this as a triangle, means radius started moving from here, delta theta angle it moved, then delta x is this much, delta y is this much, and this is the hypotenuse. Delta x whole square plus delta y whole square, square root is the hypotenuse, considering this arc is a straight line, though it is not a straight line, but consider this arc is a straight line because angle is very small, then arc length is delta x whole square plus delta y whole square, square root. Now this is the arc length for the ith section, that is delta x ith section whole square plus delta y ith section whole square, square root. Now I can sum it to get the full circumference. Summation I equal to 1 to n square root delta xi whole square plus delta yi whole square. Now for each section, someone has to find. Now let's start again. Now consider this is the origin. This is the origin, and this is the x-axis. Radius starts from here, and this is first section. If this is the first section, see how much delta x, how much x change. Here x is something, and when it moved from here to here, making it as a first section, then if I draw a vertical line, this is the new x. There is a delta change in x, and there is a delta change in y. Y was 0 here. Now, if I say delta x whole square plus delta y whole square root, it will give me this arc length. Now, I'll move to second section. There again, I see what is the change in from here, what is x, where here, what is x. Change in x, change in y. Whole square, square. That is the section length of the second section. Same thing I have to repeat for the full circumference and add it. I get the circumference of the circle as repeated summation. That is summation I equal to 1 to n square root delta x is section whole square plus delta y is section whole square. And that is the circumference of a circle. That is the circumference of the circle. Anyway, this is the fundamental. We are proceeding. Now we can convert into integral calculus. How we can convert? Delta x I can change into dx and delta y I can change into dy. Delta x is section and delta y is section. If there is a repeated addition, this is fit candidate to become dx and that is fit candidate to become dy. Okay, then we can write in integration sign square root dx whole square plus dy whole square. Can you prove it? Because what, okay, it looks perfect, but one approximation we did, that the curve length we took for the IS section, it was a curve, but I took as a straight line. That is the assumption here. Then only where the net circumference is integration of the theta or x right now and the square root of dx whole square plus dy whole square, where y is function over x. Okay, that is the concept. Okay, so can you prove through other way that it is exactly dx whole square plus dy whole square root integration? Can you prove through other way? Okay, we will prove through vector now. What I'm trying to say is that through from the delta theta, from the r theta, I'm sorry, from the repeated summation frame, we came to one integral calculus. From the repeated addition, we came to integral calculus. Now through vector, we will come to integral calculus. If both are same as far as integral calculus is concerned, then our repeated summation is perfect. This is what I am saying. What is vector terminology? Vector terminology is saying that if I have P, what is your P? This is x-axis and this is y-axis. I take any point on this circumference saying P. P is x comma y. P is x comma y, where y, that is the height, and x is from the origin. From the origin, x is the width, and from the origin, y is the height. If I combine to a point P, then that is x comma y. Very much. Thank you very much. Okay. Now consider that this x comma y, if I draw, this is origin and this is the vertical. Now I take any point x comma y here. That point I draw a line from the origin and this is the radius. This is the radius because this is the origin, this is the radius. Now in that fashion, what is the radius vector representation? That is xi plus yj. If this is 0 comma 0 and this point is x comma y, the vector representation is x minus 0i plus y minus 0j. Xi plus yj. Thank you very much. Xi plus yj. Okay, now at any point x, now I have taken any point on the circumference as x comma y. Let's say it makes theta angle with the x-axis. This is hybrid polar Cartesian coordinate system where we have x-axis, y-axis, radius, theta, everything all together. Okay, in that fashion, if this vector p is making theta angle with x-axis, now consider I move theta 1 unit. You want 1 radian? No, 1 unit. 1 unit can be 1 nanoradian. 1 unit can be 1 picoradian. 1 unit can be 1 milliradian. Anything. Very small 1 radian I move the angle theta. Then how much this x comma y change? How, what do you want? I am saying that if I move, okay, consider this is x-axis and I have a line that is from the origin, it making angle theta. Then this line making angle theta, if I start from origin, it will go and touch the circumference. Consider this point is px comma y. Now if I move angle little bit, 1 unit, then there will be another line that will go and hit the the circumference. What is this angle? Consider this angle is theta plus 1. 1 is 1 unit. Earlier the angle was theta. Now theta plus 1. 1 unit I move. Very little I move. Then how much this coordinate change, right? Earlier it was x comma y. Now it is x1 comma y1. It changed, right? How much coordinate change when I change 1 unit of angle? Okay, how much coordinate change when I move 1 unit of angle? That is the question mark. I believe it is all right. How much coordinate, how much the change? It changed from x comma y to x1 comma y1. Okay, then how much is the arc change? How much is the arc change? Okay, it change in arc, right? Right now the point is x comma y. If I move the angle 1 unit, then new point is x1 comma y1. Then this proves that the point moved along the arc. What is the distance between it? I can calculate the distance, but that will be a straight line, not the arc line. Okay, give me the straight line only. Then a straight line, that the distance it moved in a fashion in a straight line only. That is the distance between x comma y and x1 comma y1, between these 2 points. Because 2 points came into the picture, I moved the angle from theta to 1 unit. Earlier angle was theta, then it was x comma y. Now angle is theta plus 1. Okay, if I move angle 1 unit, then it will not move 1 unit position back. The point will move to new point x1 comma y1. If I move 1 unit in angle, how much arc is moving? That is the question. I can draw a straight line and I can tell the approximation. How much the arc moves? Okay, thank you very much. Tell me the approximation value. That is x minus x1, x minus x1, and in y section y minus y1. Tell me the net length. Then net length will be x minus x1 whole square plus y minus y1 whole square root. If I denote this as delta x, if I denote, okay, that is that much. Okay, so that is the one scenario. That is the one scenario. Per unit, per unit, if I move the angle, per unit, if I move the angle, how much how much is the arc it moved? Now I have divided into n sections. Someone remember it? I divided it into n sections. I divided it into n sections. This is the ith section. From here to here, this circumference is the ith section. Ith section means it converges like this. This is the ith section. This is the ith section, where this length is the arc length of the ith section. If I move, this angle is theta angle from here. This angle is delta theta. From here, if I move 1 unit, then I am moving x comma y to x1 comma y1. More or less, I say delta x, delta y, it moved in x and y. Tell me how much it moved. Okay, it moved delta x whole square plus delta y whole square. If I move 1 unit, okay, if you move delta theta I unit, then because I am curious to know the full arc length when when there is gap of delta theta I. Then if 1 unit of change, 1 unit of change, if I'm sorry, 1 unit of change, it makes the movement of this point as delta xi whole square plus delta y whole square root. Then then delta theta unit of change, if I move delta theta I unit, then I have to multiply by delta theta I. That this is pseudo calculus problem. This is the pseudo code. Means what I'm trying to say is per unit change, if I'm saying per unit change, if I'm saying what is per unit change in anything. If I say y is changing per unit change in x, it is named as dy by dx. I believe it is all right. If I say that I have x-axis, I have x-axis and I have y-axis. At x-axis, at this is origin. At any point x, I have this much height. If I move 1 unit, then this is the height. How much change in the height I see? This is nothing but dy by dx. Dy by dx, the exact representation of 1 unit change brings how many unit change in the numerator? Exact representation of this is d numerator by d denominator. What is the differentiation in calculus? If I say dy by dx, Means per unit change in x brings how many unit change in y. That is dy by dx. Same thing we are saying. If I make 1 unit angle change, 1 unit angle change, how much the length it is changing, how much position vector p point is changing. Rather than saying it, I can denote in calculus now, that is dp by d theta. Okay, what is dp by d theta? I'm sorry, dp by d theta magnitude. Like I said, dp by d theta magnitude, it is exactly same as a square root of delta x whole square plus delta y whole square if there is 1 unit of change. Exactly. Can you prove it? Certainly. We will prove it. But anyway, the net length of the ith section, will be dp by dx magnitude, dp by d theta magnitude into delta theta I. If I move 1 unit, then point P, it makes a movement in the straight line as delta x whole square plus delta y whole square root. If I move delta theta I, then I have to multiply by delta theta I. Now, the net arc length is square root of delta x whole square plus delta y whole square into delta theta I, because first section is the length that it moved because there is a 1 unit of angle change. Now we are saying the square root of delta x whole square plus delta y whole square is nothing but dp by d theta. That is certainly. Okay, dp by d theta. Okay, what is dp by d theta? dp by d theta means magnitude, because p, if where p is position vector, instead of saying x comma y, I represent it as a position vector, a vector that connects from origin and point x comma y. dp by d theta, position vector. What is dp by d theta? We'll prove that it is same what we are saying, a square root of delta x whole square plus delta y whole square. Consider here, this is origin and this is point p, x comma y. This is the position vector, that is xi plus yj, p vector. Now, if I move, this is the angle theta with the x-axis. If I move one unit of angle, then this is another position vector p1, x1, comma y1. What is p1 minus p? This vector minus this vector. That will be another vector that will pass from p1 to p. P1 is as a position vector and P as a position vector. If I subtract these two vectors, that will be another vector that will pass from P1 and P. What is the vector that pass from P1 and P? P1 is x1 comma y1 and P is x comma y. That will be x minus x1i plus y minus y1j. Okay, now if I try to calculate the length of this vector, means that how much it moved, that is x minus x1 whole square plus y minus y1 whole square root. That is exactly x minus x1 we have taken as delta x only, and y minus y1 we have taken delta y. Means it is dp by d theta. Magnitude is exactly a square root of delta x whole square plus delta y whole square. Means what the concept we are saying, the ith section arc length is per unit angle movement, how much it moved, multiplied by delta theta unit of the angle. If one unit of angle change brings the arc change in delta x whole square plus delta y whole square root, then if the angle moves delta theta I, then I have to multiply by delta theta I. Means the net arc length of the ith section, we are trying to calculate through vector now. The net arc length for the ith section is dp by d theta magnitude. That is exactly same as the square root of delta x whole square plus delta y whole square root. Now we say that our arc length for the ith section is dp by d theta magnitude into delta theta I. If I sum it for I equal to 1 to n, then it will be exactly dp by d theta magnitude d theta. Makes sense? This is through the vector. What we are trying to prove through vector? We are trying to prove through vector is that if I have any position vector here p, if this is x-axis, if this is x-axis, and this is the position vector of any point p, okay, can I find change in p with change in theta? That is dp by d theta. dp by d theta will resolve into another vector that will be tangential at any point. We have proved many times. If I have a position vector and if I calculate this derivative of this position vector dp by d theta, then dp by d theta will be tangential vector. Okay, whatever it is. Can I find the change in position vector? If I say dp by d theta, magnitude talks about how much is the arc length if per theta movement. If theta is moving from here to here, then how much is the arc length it moves? That is dp by d theta magnitude. That is function over theta. It can be function over theta. If it is function over theta, then the arc movement per unit change in theta we can say in a generic manner, not required that what is the arc movement, arc length when theta is 45 degree, when theta is 90 degree, not required. In the term of theta only, we can calculate dp by d theta magnitude. If this I get in algebraic form, then we can say that for any theta, if I move one unit, then how much arc it will make? How much arc? If that one unit is very, very small, then it will more or less equivalent to the real curved arc dp by d theta. The concept is dp by d theta per unit theta change brings how much the arc length dp by d theta magnitude. This is what we have seen from the beginning only. Okay, now what is p? P is the position vector, and then we calculate the magnitude into d theta. Delta theta I become d theta. Integration of theta 0 to pi, 0 to pi, because angle is moving 90 degree and then pi only, r equal to cos theta. Someone can calculate and it will give the circumference. Now we will use same methodology in calculation of the area. Okay, we'll proceed. So we will use same methodology in calculation of the area. I have divided the circle into n parts. I have divided the circle into n parts. Circle area into n part. So this is the first part. This is the second part. This is the third part. Means if I say this is x-axis, then this is the area. This is the area of, this is the arc. This is the arc of the first part. This is the full area of the first part, full area. Second part area. Third part area. How much it is? Then what is the area of the ith part? Through the repeated summation, we have calculated the area of the ith part is 1 by 2 r square delta theta I. Please watch our previous video. It will take a long time. Okay. So if this is the x-axis and radius is moving like this, at one moment radius is like this, and that is angle theta with the x-axis. Now I consider from here I move radius delta theta I. Earlier this was the circumference. Now this is the full area. Now what is the full area of the circle? Summation of all parts. This is the ith part. First area, second area, third area. If I add for everything or n area, it will give me the full area of the circle. Summation sign I equal to 1 to n. Then area, bottom right, ith area. I is 1 to n, summation will give the full area. What is the ith area? The ith area is, if this is the radius from the x-axis angle theta, then in that fashion, if I talk about the ith section, then this is the area of the ith section. This is the arc and this angle is delta theta I. This is half 1 by 2. This 1 by 2, this radius into this arc length, that is falling perpendicular on this. That is r1 theta I, delta theta I. More or less the area of the ith part, that is a wedge kind of shape, is 1 by 2 r1. This is r1, this is r2. 1 by 2 r2 into r1 delta theta I. R1 and R2, consider it is, if it is same, then it is 1 by 2 delta theta I. If it is same, then it is R, whatever the R is, then it is 1 by 2 R square delta theta I. R is constant and that is A, then 1 by 2 A delta A square delta theta I. That is the ith section area. I can take out 1 by 2 A square being constant, summation of I equal to 1 to n delta theta I. Okay, that is the area. What is delta theta I summation? That is D. d theta. D theta 0 to pi, because we are taking pi. If I are taking radius constant, then 0 to 2 pi. In that way, 2 pi 1 by 2 a square. Pi a square is the area. Makes sense? So simple, right? In so simple way, we calculate the area of the circle. But consider that radius is function over theta. Instead of writing 1 by 2 r2 r1 delta theta I can write r1 and r2 as function of theta. 1 by 2 function over theta into function over theta delta theta I. It will be summation I equal to 1 to n 1 by 2 function over theta whole square delta theta I. This is a fit case to get converted into integration. Integration of theta 0 to pi 1 by 2 function over theta whole square d theta. Someone can create what is your function over theta? That is r equal to cos theta. Then it is 1 by 2 cos square theta d theta. Theta is 0 to pi. Will give the pi r square. Whatever is the area will come, exact area. Anyway, we will validate it through the vector the way we are saying. Can take any point on this. Take any point on the circle. Take any point on the circle at x comma y. This x comma y represents a area point. Earlier, if I taken x comma y here, then red represented a point on a curved line. If I take any x comma y on this surface, any x comma y, that would represent a point on an area. If I draw a vector from the origin and x comma y on the surface anywhere, if I draw a line, that is a position vector that represents a area point. X, any position vector can represent a line point, a area point, whatever it is. Okay, in that fashion, we have now x comma y. Now consider that, or if someone want to understand in x comma y, all right, if I take any point here as point P and that is x comma y. Now how much P would change if I change r and theta duo? Makes sense? Because it is more. Now what I'm trying to say is, earlier we were trying to find how much is the arc. I'm seeing it moved when I move 1 unit of angle. 1 unit, if I move 1 unit of angle, how much arc length it moved? That was dp by d theta magnitude. Delta x whole square plus delta y whole square root. That what we saw. Okay, now the concept is, if I now consider that if I talk about area, then there are two things. Area means two items. In polar coordinate, the items are theta and r. There are two items. Though r is function over theta, but right now there are two independent components, theta and r. Consider in that fashion, or orthogonal component theta and r. P point is x comma y. Now I'm saying, if I move 1 unit in theta and if I move 1 unit in r, what I'm trying to say, if I make 1 unit change in the area in theta and r, makes sense? Earlier I was saying how much x comma y would change if I make 1 unit of angle change. Now I am saying how much point x comma y would change if I make 1 unit of area change in r and theta. R into theta. There are two things now, r and theta. If I multiply, it becomes r into theta. If I say there is 1 unit of change in r into theta, it talks about one area. If there are two variables, if they multiply, they will form an area. If there is one variable, it will form a line. Two variables, it will form an area. How much P would make an area when there is 1 unit of area change in theta into r? Makes sense? How much unit of line the P will make? If P is going from x comma y to x1 comma y1 in the calculation of circumference, how much P moved x comma y to x1 comma y1. If I made 1 unit of angle change, if I make 1 unit of rectangular area change in theta into r fashion, then how much P would change? Consider P was here in x comma y. This proof is not there in any of the book. Anyone can try. Consider the P is here and that is x comma y. Now because of movement in hypothetical r into theta, it moved x comma y to x1 comma y1. how much area it made. What is area when it moves? It looks like a straight line, not necessarily. If I have a point here x comma y, and I have a point here called x comma y1, then how much line it changed? That is x2 minus x1 minus x whole square plus y1 minus y whole square root. This will change how much it may move, but it can move in an area fashion also. This is x comma y. This is x1 comma y1. Form an area. Makes sense? Consider two ends of a rectangle where it is a hypotenuse. It will make an area. Makes sense? Now, how much area it made? 2 point can make area also. Move it vertical and then like this, and then move it horizontal and then like this. It form a rectangle. How much rectangular region, area region x comma y made when there is a 1 unit of area change in theta and r? That is dp by d theta r. Makes sense? Okay, dp by d theta r. dp by d theta r. I believe it is all right. Means how much area position vector p makes when there is 1 unit of area change in theta into r. dp by d theta r. Whatever area it makes, that is considered that will come in vector only. If I calculate magnitude, net area that is changing, means 1 unit of area change in theta and r. We will talk more on it in next section. It will be too complex now. If I make 1 unit of area change in theta and r, it brings how many of new area it will be drawn at point P. That is dp by d theta r in resemblance, in synergy with what we did with dp by d theta. Calculate the magnitude. This is the area. If 1 unit of area change in theta and r brings dp by d theta r magnitude, then what about if I make delta theta I and r? If I move if I move, this is x-axis, this is at angle theta. Now I move delta theta I, and r is also moving. If angle I am changing delta theta I, r is moving from r1 to r2. There is change in r also. If there is change in delta theta from theta, it moved from here to here. It made delta theta. For the IS section I am talking. What is the area of IS section? Area of IS section, if I talk in the theta and r, in theta and r, not in x and y. If I talk in theta and r, hypothetical theta and r, then it will be it will be how much this area is. Okay, how much this area is. This area, if I talk this, then hypothetical it will be delta theta into delta r. What is delta theta? This is delta theta. What is delta r? This is delta r. At this point r is r1. At this point r is r2. Certainly there is delta r. r1 minus r2. There is delta r. There is delta theta because I moved like this. Now, if I say that if I make 1 unit of area change, then there is dp by d theta magnitude, that much area change is coming. If I make delta theta I into delta ri change, that is delta theta, delta theta, delta theta, delta theta I into delta ri, how much the area we will see. dp by d theta r magnitude into delta theta I into delta theta r. Delta theta ri, delta theta I into delta ri, dp by d theta r magnitude into delta theta I, delta ri. Now summation I equal to 1 to n. This is the area that it will give. What is dp by d theta r is giving? Any theta r, any point theta r, how much is the area that it would make if there is 1 unit of change? That if that comes in algebra, if that comes in algebra, then any moment I can change. Now someone is free to calculate this. Now delta theta I, delta ri, if I break this repeated summation brings into calculus, it will become integration sign. dp by d theta r, dp by d theta r. Magnitude, this will result in a vector considering p is position vector. magnitude into delta theta I delta Ri d theta dr. Someone can calculate dp by d theta r, dp by d theta dr. What is dp by d theta r? That we will see. That will become dp by d theta cross product dp by dr. No, 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 no. Can we say something dp by d theta into dr? No. That will break into dp by d theta cross product dp by dr. How it will become, that we will see. dp by d theta r will break into dp by d theta cross product dp by dr. This is a vector, and then magnitude, then d theta dr. It will give whatever it comes, then integrate over the limit for the r and theta, you will get the area. This is the way to calculate the okay. Now this should be same as what we did in the calculation of the IS section area. That was 1 by 2 function over theta whole square d theta. But anyone will say, I remember through the repeated addition you came to integration. I remember that is integration sign, and then 1 by 2 function over theta whole square d theta. But here you are saying integration sign dp by d theta cross dp by dr, right? And then magnitude d theta dr are both same. 1 by 2 integration function over theta whole square d theta. Is it same as integration magnitude of dp by d theta cross dp by dr, d theta dr? Are these two same? It will be same. If it is same, then our repeated addition concept is perfect, that we can bring in integration from the repeated addition only. This is something, if someone cracks it, then probability is his only. Anyway, these things are not available in any of the way. This is pure research thing that we are pursuing here only. Anyway, please do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +9 was the India country code. 9483160610 is the telephone number.